Alrighty, everyone ready? So, you might have noticed that I put up your second semester assignment on web courses. Alright, so for the second semester assignment, your main assignment, you can do whatever you like. Okay? It must be developed in an OO language based on OO principles. So you must include encapsulation, inheritance, polymorphism. You can do it in any of the OO languages. You can do it in C#, you can do it in C++, you can do it in Java, you can use Objective-C if you want to make an iPhone native app. Alright, so you will have to go and do your own research. You can make a game, you can make an app. You can do it in Python. So any of the OO languages, classes, inheritance, polymorphism, files and strings, collections and generics. So I've given a few little example ones that you might want to make. For example, you could, like, if you can't think of an idea, you can make a virtual musical instrument in C#. By that I mean a little piano on the screen that you click at either with your finger, if you want to make it for the iPad or something, or with the mouse and it plays musical notes, or something like a guitar, so you can go and record some sounds and have the thing make a sound like a soundboard, right? But with a real musical instrument. So that's something that's definitely achievable by everybody, right? So that's like the baseline assignment if you can't come up with something. If you're not interested in games or whatever, make an app, okay? Make something, you know, pick your hobby, pick your sports club, whatever, make an app for them, okay? So do whatever you like, basically. You can, I prefer everybody to do this individually. So you, the rules for team assignments are, if you're doing any of the following, if you are doing an Imagine Cup project, like Jason and who else is on your team? Tanya, and Sean, right? That's fine. You can do that, okay? In which case, your assignment is due next week, because that's when the Imagine Cup is, right? You can continue to move on, right? Afterwards, you know, next week is the finals, right?
Oh yeah.
Yeah. So you can continue to work on it afterwards, okay, that's fine. Another option is to do GamesFly, right? If you can do a team project if you're specifically targeting GamesFly, in which case your assignment deadline is in 3 weeks, because that's when GamesFly is. Now the thing about GamesFly is, last year we took down, I think it was either 5 or 6 teams competed. This year it will be no more than 20 students at GamesFly, right? And it will be competitive. So I anticipate, like, there's a couple of third-year teams already. There's a couple of second-year from 2 to 8 teams already. So if you want to do GamesFly, you'll have to compete for your space to represent DIT. It's not guaranteed that you'll be able to go down. So what I'll do with that is I will find some other people other than me, probably Hugh McTamney who's the chair of the MSc in Creative Digital Games over at Angel Street, and maybe 1 or 2 people from the games industry to judge the games that are submitted, and we'll decide who are the ones that are going to represent DIT. Now, GamesFly is the best crack. It's absolutely brilliant crack, right? It's basically 2 days. We go down on Tuesday. You're competing on Wednesday, so you're going to get judged multiple times by different groups of judges. They're all from the industry. They're all looking for interns. They're looking for work placement students. They're looking for people to do work for them. They're looking for portfolio pieces. Okay, so you have that option, right? And then the evening time is brilliant. There's a thing called they call it like the GamesFly session. It's a trad session in a pub called the Monks. And then there's table quizzes, and then there's loads of gaming tournaments, stuff like Call of Duty and Guitar Hero and stuff like that over the 2 days. And on the second day, there's an expo. Alright, so your games are going to be on display besides the top indie games from the Irish games industry as well, and you guys will be there representing, you know, yourselves and your team. So it is a great opportunity. You know, GamesFly is a fantastic opportunity, and we've had some success at GamesFly in the past. We won loads of things last year, but we didn't win the main prize. Previous year we won the main prize, the overall XNA Ireland Champions Cup, and that was a Connect game. So I just want to let you know as well that the standard at GamesFly is high. And if your game doesn't meet the standard, you won't be allowed to compete, because we want only, you know, you have to meet the standard, and the standard is pretty high. You know, to win at GamesFly, I think it's even maybe tougher than the Imagine Cup, because it's a theme, and people sort of tend to take to the theme. This year the theme is tanks, so you just have to do something which is some sort of X and A game, something to do with tanks. So you can do a bit of research into tank games and stuff. As long as your games have tanks in them, I think they're eligible. So that's the second option. You can do an X and A, and that's okay. If you want to be in a team, you can do that. Otherwise, it's an individual assignment. Okay, you can use the Mono Touch or Mono Droid framework if you want to do an app for iPhone or Android. So you can write it in C#. You've got to figure out how to do Mono Touch or Mono Droid. There's loads of YouTube tutorials. I expect you to do your own research and to do some discovery and to learn something new yourselves to bring to this project. You're not going to learn everything that you need to complete the assignment and get a first in it. To get a high mark in this, you're going to have to go and learn something yourselves outside of the class and discover your own things. Alternatively, you can do a native app. So one thing that's like hugely in demand at the moment is native iOS developers. If you have a Mac, for example, and you want to learn the Objective-C language and make an app, which people did last year for assignments, that's absolutely cool. I just couldn't recommend that more highly because I just constantly get phoned by people looking for app developers for short contracts. So you can get $1,000 or $2,000 or $5,000 or whatever for making an app for a company, and you can do that while you're a student. And you know, I just have a queue of companies looking for iOS developers, and I don't have any. So if you can learn Objective-C and you have an Apple Mac, I think that would be a really, really great use of your time this semester. And you know, iOS developers in London earn like 120 grand sterling a year after a couple of years. You know, even in Dublin, a good iOS developer, they're just like gold dust. So, you know, it's something that would be very worthy and worthwhile for you to do if you have an Apple Mac, is to do an iOS native app. And they're not, you know, after you get used to Objective-C and all the weirdness, I'll give you one class, crash course, on how to make an app using Xcode at some stage during this semester, once we've got some more of the core stuff over with. So that's a couple of ideas. Alternatively, an Android app. So you can do an Android native app using Java. You know, just go up and download Eclipse. Again, I'll give you a one-day or couple of hours crash course on the Java programming language. It's very similar to Objective-C. Or you can use the Mono Develop framework. So you can use the Objective-C language that you're learning on this course to make either an iOS or an Android app or a cross-platform app or a Windows Phone app or a Windows 8 app, tablet app, whatever you want. So you have to find your own way to discover programming this semester, and that's what your second semester assignment is all about. Now, there is your first deliverable is due next week. And your first deliverable is very simple, and I don't want you to complain, oh my god, we've got too many assignments to do. I don't want people to go mad on this. I just need two things off everybody for next week. Number one, you have to document your journey on this project in a blog. Okay? So everybody, go up to blogger.com or Tumblr or WordPress and create a blog for yourself. Very importantly, make sure that the blog is publicly accessible. That you don't have to add me as a collaborator in your blog in order for me to be able to see the blog, okay? And then I need you to document your journey on this project over the rest of the semester in your blog. So every week I'd like to see an update, right? This week I did this week I've downloaded Eclipse, I figured out, wrote my first Java program, whatever. Something every week into your blog. And this is like the continuous part of the continuous assessment for semester 2. The next thing I need is a very, very short document, just saying, this is what I propose to do, I'm going to use these languages, whatever. Alright, so that's all that's due next week. It's just to have a think about it, have to sign it. Yeah?
So you submit that document, is it still okay to change your mind?
Of course. Yeah. This is just for fun. This is going to be a very small percentage of your overall mark, right? So it's mostly for your benefit. I mean, in the hope that you will sort of, like I say, discover something or find a project which is important for you to make. Alright, so like I'm saying, if you have a sports club or you're interested in music or something like that, then make something around that. You know, yeah, but it's okay to change. Yeah.
Just a quick one, you know.
But document everything on your blog. That's the whole point, it's your journey. If you look at the marking scheme. Sorry, Jason.
No, it's just a really quick one. You know the Magic Cup thing?
Yeah.
Obviously, for next week we're having our thing done in HTML5 and
yeah, sure.
Stuff, which isn't OO.
That's
so
fine.
For our assignment, can we just make a native iOS version of it?
That would be great.
That'd be okay?
Yeah, that would be fantastic. Yeah. The other thing is, if you're doing either one of the competitions or you are planning to commercialize, in other words, you have a little business that you want to start selling an app and you have an idea for an app that you want to write, then you can do it in a team. In other words, if you're thinking bigger than just the course, and you think it would require more than one person to do. So just, not you guys specifically, but we'll say across the whole of second year, right? There was a number of people that did team projects for the first assignment. And, you know, some of them were great, some of them were really outstanding, but some of them really were one-person projects, right? But people just kind of said, oh, well, I haven't got any assignment done here, just put me on your team, right? So I want to avoid that this semester. So unless your project is big enough to require multiple people, then you have to do it individually, okay? Because it's about your story and your journey and your you know, your thing with programming, your love of programming that you're hopefully going to develop. So the way it's going to work is it's a very open marking scheme, like a fourth year project marking scheme, right? In other words, I'm not going to say if you include 5 classes you get 10 marks, etc., right? The marking scheme, this is out of 100, okay? And then towards the end of the semester, we'll balance up all of the 4 assignments, right? 20% for features, 20% for complexity, 20% for OO quality. So I'm looking for the right number of classes and classes to represent the right things. 20% for documentation, which goes for number 1, your blog, and number 2, your test plan. So once you're finished your assignment, you submit a short document explaining, well, okay, I made this thing, and this is how I tested to make sure that it reached the requirements, or that it did what it was supposed to do. So a short little test plan document. And 20% for project management. Now, how the project management works is, again, it goes for your blog. So if I just see your blog at the end of this, because I'll hopefully get to see your assignments a few stages during the semester, but if I just see your assignment right at the very end, and I see that you've just put 1 entry in your blog, then that means you left everything till the last minute. Alright, so I need to see a little bit of progress every week on the blog, and that's where your project management mark goes for. So even if your assignment doesn't do what it's supposed to do, okay, if you don't achieve what you say you set out in your proposal document, but by the end of the semester I see that you've done a little bit of work every week towards it, then you'll get to 20 marks for the project management. Is that okay with everyone? Does anybody want to ask me any questions about it?
Could you explain a little bit more about the test plan? What does that entail? What do you want?
So you know what I'll do? I'll give you a couple of examples of what I previously did last year. So you might say, for example, okay, say your app has 5 different features. You know, say it allows you to log in, and then say it allows you to present a list of something and allows you to add and remove things from a list, right? So how did you test it? You know, did you test logging in? Did you try turning off the internet to make sure that it still worked? So, you know, how would you even consider testing it to make sure it worked?
So it's a written document.
A written document.
Of like test
exactly. Test case. This is how I test. This was the result.
Yeah.
Exactly. Yeah. So just like, you know, 3 to 4 columns, and a little test scenario, the outcome of your test scenario. All right. Is that okay with everyone? So that's it. Due date. Somewhere towards the end of the semester. Is Paula here today? I'll work with Paula and we'll arrange a date which everybody is happy with. Alright, but your first one is due next week. And there's no need to get too stressed out about it. It's just a short document and what you plan to do, just to get you thinking about it. Alright? Okay, have fun. Have fun. You know, over Christmas and for the last few weeks I've been working really hard on the new version of this, which is kind of my life's work, TunePal, yeah? So I've told you all about TunePal before, but I mean, I consider it, in a way, it's like, I feel it's an honor every time I have the opportunity to reach out and make a new version. I put an extra 5,000 tunes in the database collection, you know, and I worked on transposition and variant searches, key invariant, so you can play a tune in any key and it will find the match. And I have 700 likes on Facebook. Make a Facebook page for your thing, whatever you're doing. It's great. And try and get likes and stuff. And, you know, I get people emailing me from all over the world. It's very exciting. And most interestingly and most excitingly of all, maybe for you guys, I make a lot of money selling TunePal. I make a fair bit of money. Every day I log on. It's not the money. It's the idea that somebody out there thinks the thing I made is cool enough that they want to give me 4 quid for it. And that's just an awesome feeling. Every day I log on to my iTunes Connect account and I find, hey, I made another 50 quid today. And then my Google Play account, oh wow, I made another 200 quid this month. It's great. You know, that money that you make selling that thing, even though I tend to, you know, put a lot of it back into the project because I've got to pay for hosting and I go to conferences and whatever, you know, for me that's much more meaningful for me than the money I make teaching you guys. I love teaching you guys, but this is my thing. I mean, long after I've forgotten as being a lecturer, they go, oh, that's Brian, he's the guy that made TunePal. So I'm famous for being a programmer and taking my other thing, which is playing the wooden flute, which is my big passion. And then when I'm finished this phase of TunePal, wait till you see, by the summertime, I'll have my CD out, because that's my next big project, right? I bought a whole lot of audio equipment. You know, I've got an M-Box, I've got 2 microphones, I've got Pro Tools, I'm teaching myself how to use it, I'm doing some recordings, figuring out how to add reverb and the whole thing. By the summertime, I'll have my CD out. But that'll be the next phase. But yeah. But yeah, write computer programs for fun and profit. And that's your assignment. Okay? Is that alright with everybody? Okay. So, and you know, it doesn't have to be a game. You know, if games are just easy because a lot of people play them and they're definitely achievable for you to put something simple together in terms of a game. But make an app instead. Or just, you know, whatever it is that you're excited about in life. Try and incorporate something like that into your assignment. Okay, so we'll get back to operator overloading, right? And I just want to run through the example we did last week and go through the solution for the first part of the lab. And then, how many people got the first part of the lab finished? Just doing all the vectors and the magnitudes of. How many people got the second part finished? The matrix? No problem. You can work on the matrix this week in the lab. Okay, so over the next few weeks, in order to do this spell checker program that we're working on, we need a matrix class. We need something that can represent the matrix. You can pass in the rows and columns into the constructor, you can set different fields, and you can set up the matrix whatever you want, right? So we need that class to do our spell checker. So we'll work on that in the lab this week. And one thing I'd like everybody to try and develop themselves, you can do it this week in the lab, is to do, have you guys multiplied matrices before? Did you do that in C with Michael Collins in first year? Or algorithms, or maths? Did you write a program to do it? Cool. You're going to be writing a program to do it. It's great. You'll love it. Okay. So first of all, if you remember from last week, what we were trying to do is we were trying to make a reusable class to represent a little maths object, a vector object. All right, and we can set things like the x and y, and then we can do stuff like calculate the magnitude of the vector. We can add vectors, we can subtract them, and we can multiply them in 2 different ways. And that's what we made in the class last week. So just take a quick look at the vector class. All right, and this is the vector class that I made for you guys. It's up on the website. So first of all, we have these things, float x and y. What do we call these? They're called fields. All right, so they're fields in the vector class. And if I don't put anything in front of this, what's the default access modifier for them? They're private, okay? Which means that you can't get access to these outside the class. And then we have these things here. What do we call these things? They have getters and setters, so they're called properties, right? So this has fields called x and y and properties with an uppercase x and an uppercase y. Here's an example of this method here, which has got the same name as the class. So what do we call this guy? So it's called a constructor. Remember yesterday in the multi-choice quiz we were saying constructors don't return a value. So constructor doesn't return anything. It just sets the current instance. It gets constructed by the C# or the .NET runtime, and then the constructor is used to initialize it. So you can tell it what its x and y is. All right, and this is how you do. You go this.x equals the x parameter. What does this refer to? Yeah, it's a reference to the current object. All right, so it's the current vector. And this we're saying the x and y here, and this is the current x and y. Look at this example here. This is an example of what do we call this type of constructor here. It doesn't take any parameters. It's called a default constructor. All right, it doesn't take any parameters. And what does this do? When you go colon this, what's that an example of? Constructor chaining. So I'm making use of this constructor to initialize it with default values. You see that? Because I'm not telling it what its x and y is. So the default constructor is saying, hey, if you don't say what x and y you are, your x and y are 0 and 0. So that sets up a vector with values of 0 and 0. So then I make this here, public float length. What's length? What is it? Just looking at the code without even understanding what the code does. It's a property. Okay, so it's another property. So all vectors have a length, which is the distance from the origin to the x and y coordinate, which you calculate as the square root of the x's plus the square root, the x's to be squared plus the y's to be squared, right? So this one here, the fact that it has a get and not a set, what does that indicate? It's read only. In other words, you can get the length of a vector, but you can't go v.length equals 10. You can't tell a vector what its length is. You can only get the length of the vector, and that's the significance that it has a get but not a set. So then you can look at this code here. It's just math.square root, math.pow x to the 2 plus math.pow y to the 2. So that just takes the x to be squared, the y to be squared, and then gets the square root of it. Can anyone remember, what does normalizing a vector mean? What's the length of a vector which is normalized? 1. It's 1. And how do you normalize a vector? You divide the x component by its length and you divide the y component by its length. Here's an interesting thing here. Look at this. The fact that this is static, what does that mean? What's a static method? Come on, we only did it yesterday. The fact that it's static, what does that mean? It can be called without an instance. So how do you normalize a vector without there being an instance of a vector? You have to pass the vector in as a parameter. So this doesn't change the current vector, because there's no this. You can't use this in the static method, because there's no current object. There's no reference to the current object, because there isn't one. So this just basically passes in a parameter a, calculates the length of a, and then returns a new vector, which is just the x component of the vector divided by the length. And, that's a mistake, that should be the y component by the length. You notice here I can use a.x and a.y here, and I'm using the, which one am I using, the field or the property? I'm using the field. How can I use the field? When the field is private. What's that? Yeah, exactly. Normalize is a method on the C vector class, which means you can access the private members of the vector. That's what private means. It means only the class itself can get access to it. So this just saves me calling a method, you know. I could equally use a.uppercase x, in which case it would use the property rather than the field. Is that okay? Is that alright with everyone? So that's how we normalize a vector. You pass in a vector, it returns it. And then the arithmetic operations here. So all arithmetic operations, when you define them in C# are statics. They're all statics. So this is the first operator. And these operators are built, if you like, to take advantage. So we start with one operator and then try and build all the operators based on the previous ones. This is a good strategy. You know, saves you copying and pasting code. So first of all, I got the operator plus, which implements the plus operator. When you implement the plus, what operator do you get for free? Plus equals. You also get the plus equals to operator for free. Okay, so this takes two vectors, A and B, and returns a new vector. It just adds the x's, adds the y's together, and that's how you add two vectors. So now I can declare two vectors. I can go vector A, vector B. I can go C equals A plus B, and it will call this method and pass in these two guys here as a parameter. Is that okay? That's how operator overloading works. So then we implement the single, the unary negation operator, which just negates a vector. So it just returns the vector, and we negate the x, negates the y, so returning a new vector. The next one here is actually the subtraction operator, but I'm going to build the subtraction operator from the previous two operators. So the right way to do this is to pass in the two parameters and go, we return a plus minus b. So what this will do is it will negate the b parameter and then add it to a. Is that okay with everyone? So that's the right way to implement the subtraction operator. And when you implement the subtraction operator, what operator do you get for free? You get minus equals. Once you implement plus, you also get plus equals. Once you implement minus, you also get minus equals. This is way more simple than in C++. In C++, you have to implement both of them. In C# it says, well, there's no point in implementing it differently. So you implement one and you get both. So then this operator here is multiplying a vector by a scalar. And so this just basically takes the x component multiplied by the scalar and the y component by the scalar. And this one here multiplies two vectors, returning a scalar. So what do we call this operator? It's multiplying two vectors and returning a scalar. It's called the vector. Can anyone remember? You guys should be writing this down if you don't remember anything. It's called the vector.
Is it the magnitude?
No, the magnitude is the length, yeah? It's called a vector dot product. When you multiply two vectors and you return a float, it's called a vector dot product. So then I implement these operators, and you don't really know what does plus plus do when you do it to a vector. Well, I basically just said it normalizes the vector and adds the normal vector. So it basically adds 1 to the length, but keeps the magnitude, and the same for the subtraction operator. So these ones we didn't do last week. Sure, we didn't. The equality operator. We didn't do this last week, did we? So here are these extra ones, right? If I want to check to see are two vectors equal, they have to have the same x's and the same y's. So the equality operator takes a and b and it returns a bool. So it's going to return, is the a vector equals to the b vector? So what does it have to do? It compares the x's, compares the y's. If the x's and the y's are the same, then you return true. Does everybody understand that? So if I want to compare two vectors, the vector 5, 5 and the vector 10, 10, it's going to compare 5 with 10, 5 with 10. If they're not equal, it returns false. So we compare the x's, compare the y's. If they're equal, we return true. And that's how you tell if two vectors are equal. Is that okay? The not equals to operator. This is a cool way to implement not equals to. You go a equals to b, and then you not it. So this just reuses the existing one. The problem with, the problem with copying and pasting is that you do something like this. You copy this like this, and you bring it down to here because you say, yeah, it's just the same as the equals, but you just change and you go like that, and you forget to change the other one, or you do something stupid and it doesn't end up. So you end up implementing equals and not equals, and they're not the opposite to each other. So if you screw up slightly, it's much better to reuse the existing one and just go not equals like that. So now we can check to see are two vectors equal and not equals. If you implement the equals operator and you don't implement these two methods here, get hash code and equals, you get a warning in C# to say that you're meant to overload those ones as well. I'll just explain what these mean. I don't exactly know what equals here means, right? But you'll get, I guess it's part of the object class, and if you overload equals like this, you're meant to also overload this method here. You're meant to override it from the base class object. Now, get hash code. Anyone idea what that's about? Alright, so there's a data structure we haven't come across yet called a map. Alright, so how a map works is a map maps keys to values. So we're used to arrays. Everybody knows what an array is. So an array maps numbers to values. So you say, get me array index number 10, it will get you the 10th one out of the array. Alright, a map maps objects to objects. So for example, you could map students to student numbers using a map. Alright, and in order to implement a map, you have to implement this thing called get hash code. So it just has to return some integer which uniquely identifies the number. So I basically just said it's the x value and the y value. So we haven't done the hash table. We'll do it later on in the semester when we're looking at different data structures that are built into C#. But a hash table or a map is a very efficient data structure if you want to implement like lookups, index lookups. If you have 1 billion student records, or you have a record for every human on earth, and I want to look up somebody by their last name, you don't want to have to go all the way from 0 all the way up as far as 4 billion. What you want to do is a thing called a binary search tree, so you can efficiently search through huge numbers of huge amounts of data. Did you do this in algorithms, or did you come across a big O notation for this? We'll get to it, right? We'll get to it, but it's an efficient way of looking up large amounts of data, and you have to implement get hash code. So I also implemented these less than and greater than ones. This is pretty straightforward. How do you tell if two vectors are less than or equal to each other? Well, I just said get the lengths of the vectors and compare them. And then the same for the greater than operator. I just said not less than. And then the less than or equals to operator, So it's either less than or equals. And then the greater than or equal operator are not less than or equals. So there's all the operators. And finally, the toString. So toString, like we said yesterday in the multi-choice quiz, converts the object to a string. So I just, generate a bracket plus the X plus the tab key. I should really put a comma in there. Wouldn't that be nicer? Comma space, the Y value plus a closed bracket. And that's it for the operators. Is that all right? So that example is up on your website, right? You need to know how to implement all of those operators from scratch yourselves. So we look at the solution to the lab, okay? In the lab, we had, first of all, part 1, sum the following vectors. This is a really quick way to sum the following vectors, right? Look at this, all in one line. Just go sum equals new C vector 9, 8 plus new C vector 100, 1000 plus new C vector minus 9, minus 9. An alternative way to do that is to declare 3 vectors, do the initialization, and then add the 3 values. But this is, if I was doing this and I just knew I had these 3 values to do, or you could put them into an array and you could just iterate through the array and sum them up that way. But basically you just want to add the 3 vectors. So that's it in one line. Is that alright? Next thing, calculating the magnitude of the vector. Magnitude is the same as saying the length of the vector. I'll do this and then I'll just do some stuff on the whiteboard, right? So, this is magnitude of the vector, just calculate the length. So that's the next thing. The distance between 2 vectors. How many people calculated the length of the 2 vectors and subtracted one from the other? Did anyone do that? That's not the right way to calculate the distance between 2 vectors. What you have to do is subtract one vector from the other and calculate the length of it. So I just have v1 and v2, and the distance is equals to, watch this, very nice C# code here. Look at this, v1 minus v2, which returns a vector, and then you just call dot length on that. You see that? Alternatively, declare another C vector, and just go v3 equals v2 minus v1. And then v3 is going to be, the length of that is going to be the distance between v2 and v1. So v3 dot length. So I'll show you the code and then we'll take a look at what this means in actuality. So in the multiply by operators, multiply by equals, so that's pretty straightforward. To calculate the angle between 2 vectors, what we're looking to do is to make use of the multiply by operator here. So remember the equation I gave you last week? A dotted would be over the length of A times the length of B, and you get the inverse cosine of it. So here we go. Theta being the angle between the 2 vectors, math.a cos, v5 multiplied by v6, this is the dot product, divided by v5 dot length multiplied by v6 dot length, and then you get the angle between the 2 vectors. And then I have this little method here called radians to degrees, which calculates it in degrees. Is that okay with everyone? That's the solution to part 1 of your lab last week. Okay, we'll just use the whiteboard then for the rest of the thing. I'll put that up on the course so you can have a look at it. I think I should probably show you an example of the vector dot product for real, to show you what you actually use it for. I'll show it to you in code, right? But I'll dig it up first. First of all, there's a vector A. The length of the vector is the distance from the origin to the vector, like that. That's how you calculate the length. So it's the x squared plus the y squared, and then you get the square root of it. So that's what I mean when the magnitude or the length of the vector is the distance from the origin to the vector. Is that okay? Then we might have vector B, and I want to get the distance from A to B. So you might think initially I'll get the length of A, I'll get the length of B, and then I'll get the distance between those. That's not how you calculate the distance between 2 vectors. This is the way I like to think of the distance between 2 vectors, right? You can only get the length of a vector, so you can get the distance from the origin to a vector, right? So watch this. If I move A to the origin, then A becomes 0, 0. If I want to move B by the same amount, what do I do? If I've moved A to the origin, I want to move B by the same amount. just take A from B, okay? Because, you know, if A was the vector 10, 10, and B was the vector over 20 and down 5, if I move this to the origin, I've subtracted 10 and subtracted 10 from it. Alright, so this becomes 0, 0. If you take the vector B and move it by the same amount, then this becomes the vector 10 and minus 5, doesn't it? Because I subtract the same amount, so it becomes this vector up here. Over 10 and minus 5. So that's the vector B, and I have now moved the vector A to the origin, and this is now UA. And look, that distance from there to there is the same as, not in this stupid diagram, but it's basically the same as that distance from there to there, isn't it? Can you see that? So I move A to the origin, move B by the same amount, and now all I need to do is get the length of this vector. Do you see that? So to get the distance between two vectors, what you do is you just get A minus B, and you get the length of that. And that's the distance between two vectors. So you can do it the same way. You can do B minus A, and you can get the length of, you know, that vector. And that's the same as the distance between B minus A and A minus B. So that's a very simple rule. To calculate